Hi everyone, today will be our last official question on ionic equilibrium. So moving forward, our next topic will be on kinetics. If you have any questions, we'll be introducing this new segment whereby you can send in any questions related to this topic that we'll be doing to our phone number below. Please read the header for our phone number to send it to. Okay, so let's go into this last question today. The equilibrium constant for the reaction represented by the following equation is smaller than 1. Which of the following gives the correct relative strengths of acids and bases in this reaction? So for this type of question, it's actually a mixture of ionic equilibrium as well as your understanding on chemical equilibrium, Le Chatelier's principle. So this is one of the more difficult questions that you can see. So therefore, I've included this here today. So over here, let's take a look at the equation. Over here, you see that I have HPO4 2 minus. And what did it become? It became H2PO4 minus. Therefore, over here, my HPO4 2 minus gained a proton. Okay, so if it gains hydrogen, it is a proton acceptor. And this is a Bronsted-Lowry base. So hence, HPO4 2 minus is the base and H2PO4 minus is the conjugate acid. So next, I have H2BO3 minus and it became HBO3 2 minus. So over here, it has lost a H plus. Therefore, over here, H2BO3 minus is a proton donor. Therefore, it is a Bronsted-Lowry acid. So this is an acid, and HBO3 2 minus is the conjugate base. Okay, so over here, let's see whether we can eliminate anything that's not in the right place. So let me look at acids. So acids, I'll have H2BO3 minus as well as H2PO4 minus. So I can eliminate D and C. So over here, I'm left with A and B. Next, let's take a look at this piece of information that they've given us. They mentioned that the equilibrium constant is smaller than 1. So what is equilibrium constant? That is the Kc. So Kc equals to concentration of products over the concentration of reactants. Hence, if the value is smaller than 1, what does it tell us? It tells us that we have more reactants than products. Because in order for it to be smaller than 1, it means that the denominator should be a larger number. For example, 1 over 2 versus 1 over 1. Okay, so 1 over 1 will give you 1, and 1 over 2 give you 0.5. So you see, the larger the denominator, the smaller the Kc value. So therefore, this tells us that if the Kc is smaller than 1, it means that there's more reactants than the products. Okay, so if there's more reactants than products, that means that the POE of this reaction, point of equilibrium, lies more to the left. Okay, so the POE lies more to the left. So over here, we have to understand that between weak bases and strong acids or bases, in general, weak acids or bases are lower in energy than your strong acids or bases. We also need to know that in a reaction, equilibrium favors the side with lower energy. Hence, Over here, since the POE lies to the left, it means the left-hand side has lower energy. So this means that this side is weak. So therefore, on the left, I have my weak base and weak acid. And on the right-hand side, I have my strong acid and my strong base. So then let's look at the answer. So comparing my acids, definitely the stronger one will be H2PO4 minus. So therefore that will be A. And looking at my bases, it'll be HBO3 2 minus, that is stronger. Therefore, my answer is A. So okay, we've come to the end of ionic equilibrium. And the next topic that we'll be uploading later today will be on kinetics. So again, if you have any questions, please don't hesitate to send a question to me. Also, if you feel that you are facing some problems with H2 chemistry, please do not hesitate to, again, reach out to us via WhatsApp or visit our website for our group tuition. Thank you and have a nice day.